So your test is next class. I didn't put on your previous tests you've had on the front page like a big matching vocabulary. That's not on there, but you absolutely need to know the difference between a synthesis and a double replacement and a single replacement and neutralization and the opposite of synthesis, decomposition, and then a combustion. You need to know what those mean and what they look like. You also absolutely need to know words like catalyst and concentration. And so on the crossword puzzle that I gave you, which is usually where I steal the vocabulary from, I think this time it's going to be much more of a, hey, which of the following is a synthesis? Which of the following is a decomposition? So you need to know those words before you can figure out what the reactions are. Kinda like this quiz. Who's my favorite student? I am, Mr. Dueck. Well, only if your name is good old Ann Serkey. Okay. A says classify. I'm going to do all of the classifying first, then I'm going to go back and balance. Okay? Because if you can classify, I mean, that step, you got to be able to figure out what's going on first. Here, this is a single replacement, right? The magnesium is bumping the hydrogen. This is two things and two things. This is either double replacement or neutralization. Oh, base, acid. You know what? This is a neutralization. You get 1 mark for the classification, and then we'll go back and give you 1 mark for the balancing. This is synthesis. You're combining two things into one. Here I see one thing being broken up into two smaller things. This is a decomposition, the opposite of synthesis. This is a synthesis. Boy, that's tough to say. This is nitrogen and oxygen combining to form dinitrogen pentoxide. I think we would call that because that's covalent. It's two nonmetals. Let's see here. You know what? This is a double replacement, I think. I see two things plus two things, and I see stuff swapping partners. C's and O's, you know what? This is a combustion. Next one, single thing, two things, and the aluminum is bumping out the nickel. This is a single replacement. This is a single replacement. Again, if you haven't done the quiz, don't write this down. I'll be putting the quiz online anyways. The answer's online anyways. I see some of you writing stuff down. I hope you're doing corrections, but even then, hey, try the corrections later. Email me your score, and I'll change your score. Boy, let's finish off. Let's balance the front page. So, balancing. Here we go. So, on a test, I probably, Courtney, would show more work, but what I've told you is I want to see if we can get good enough to do these. I'll say in my head. You're not, what I mean is without showing all our work. So what I do is I look for what's not matching. How many magnesiums here? 1, 1. So I'm good with that. How many chlorines here? 1. How many here? Okay, so the first thing that I might say is I'm going to need 2 chlorines on the left. Chlorines match, magnesiums match. Ty, my friend, how many hydrogens are now here on the left? How many on the right? Ah, there. Balanced. So 1 mark for that, 1 mark for putting the 2 there. Let's see here. How many calciums? 1. How many calciums? 1. How many SO4s? 1. How many SO4s? 1. Mr. Dueck, wait a minute. Why didn't you do the... Because I know the OH and that H are going to combine over here. So let's see. How many H's? 2. And another 2 makes 4. How many H's over here? Right now, 2. How can I change that, Kyle? And if I'm lucky, maybe that took care of the oxygens as well, because now I have 2 oxygens on this side, and I have 2 oxygens. Mr. Dueck, why didn't you count those oxygens? I treated the SO4 like one funky atom, like one funky molecule. I think that one balances with just a 2 there, I think. I need 2 ALs, and I need, I I think 3 there and 2 there. That gives me 6, and that gives me 6, but this is not going to work anymore. Do you have to go with 4, 3, and 2? Okay. I'm going quick. If you want me to go do one of these slower afterwards, feel free to ask, and I'll go through it in more detail. Yeah?
Is it 1 mark?
Oh, so what I would do for this, since there's 3 things, I would say you have a total of 1 mark to start off, and anything you're missing, you lose a half mark. But yeah, 1 mark for the balance, 1 mark for the identify the type. Probably I should go 2 marks for balancing, but this quiz is already out of 48. That was enough as far as I was concerned. KClO3 becomes KCl and O2. The K's match. The Cl's match. The bleh. How many oxygens on the left? 3. How many on the right? 2. What do I want to turn those both into? Yeah, you spotted that you kind of do a little cross-multiply trick and clue in that's what your goal is. So the first thing I might try is putting a 3 there and try putting a 2 there, which now balances the oxygens. But now, Sage, I've changed the potassiums. I got 2, so I might try putting a 2 there. And holy smokes, I think that also took care of the chlorines. So this one is 2, 2, 3. Ugh. Number 5. I got the nitrogens match right now. I got 2 oxygens on the left, 5 on the right. What do I want to turn them both into? 10, right? So my first guess is putting a 2 there and a 5 there. That gives me 10 oxygens. But now, Taylor, I've just changed the nitrogens. Now I have 4 nitrogens. 2 times 2 is 4. Hey, wait a minute. I can fix that right there. 2, 5, 2 balances that equation. There's a bit of a science to these, a bit of an art to these, and you get kind of good at these. And I apologize. The only way I know how to get good at these is to throw a zillion of these at you. But you'll thank me if you take chem next year. Holy smokes, is number 6 balanced? 1, 1, 1, 1, and 1. Woohoo! So if you left it blank, you get 1 mark.
Well, that's good because I didn't do the quiz.
No, you don't get 1 mark if you didn't do the... Anyways. Number 7, these ones I always find tough. Start with the carbons. So I got 5, I got 1. So the first thing I might think is maybe I'll put a 5 there. Then I do the hydrogens, then I save the oxygens for last. Hydrogens, I got 12. Right now I got 2. I can put a 6 there, that gives me 12. Oxygens, on the right I have, how many oxygens here? 10 and 6. How many oxygens do I have on the right? 16. Is that right? Is it 1856 or blank 856? Those ones I always find tough. Number 8. Well, my BRs don't match. I got 2, I got 3. I want to turn them both into a 6. So put a 3 there, put a 2 there. Now, what has that changed? Putting a 3 there gives me 3 nickels and... Is that right? 2, 3, 2, 3? That does it? So this page is out of 16. I have to turn the page. You guys are moving 1 page over. Let's classify as well. This is going to be synthesis. This is going to be single... First one is decomposition, not synthesis. Of course it is. I never make mistakes. Whoops. Sorry, number 9 is decomposition. I read it somehow going the other way, which would be synthesis. 10 is single replacement. 11 is double replacement. 12 is neutralization. I see an acid, I see a base. 13 is combustion. 14 is decomposition. 15 is synthesis. All right, let's balance. 2 and 2. Hey, is number 10 balanced already? Oh,
Nice.
how many did I say balance already? 3? Okay, so there's 2. One more apparently will. Ugh. Ugh. Okay, I need 2 lithiums, which also gives me 2 NO3. Oh, is that just the 2 there balances it? Yes? Cool. All right, bring it on. Sodium matches. And, oh, is number 12 balanced already?
Yes.
Yeah. Uh, 13. Yeesh. Okay. How many carbons? 7. I'm not wild about that 7 there, but maybe. How many hydrogens? 16. So I'm going to put an 8 there. How many oxygens do I now have? 14 plus 8. 22. Oh, this isn't that bad. I can put an 11 there. I think, is that right? Blank 11, 7, 8? 2, 2 blank. I need 4 phosphoruses, which gives me 12 fluorides, which gives me 6.
Yep.
So, this page is also out of 15, which makes the front page really out of 31, if you want to do it that way. No, it's not out of 15, is it? 1, 2, 3, 4, 5, 6, 7. It's out of 14, Mr. Dueck, which makes the front whole page out of 30, because each one was worth 2, so how can I get an odd number? Oh. Okay. On your test, I'm going to be giving you some questions where I say predict the product. I won't ask you to balance them. Then I will give you a couple of questions like this where I ask you both to predict and balance. So predicting the products, I have to identify what the heck the product looks like. But first, I got to identify what type it is. So this is going to be a single replacement. Andrea, what that really means is this zinc is going to bump that magnesium. I'm going to end up with magnesium, and the zinc is going to combine with the SO4, but it might not combine with 1 and 1. I have to crisscross. So zinc has a charge of, here, periodic table. Zinc has a charge of, is it 3 plus? 2 plus, I think it is. And SO4, from the back of my periodic table, has a charge of 2 minus. Oh, these guys do crisscross into a 2 and 2, which reduces to a 1 and 1. So this one, although I crisscrossed Tyra, Zn, zinc, SO4, sulfate, is right. Now I balance. It is balanced. Yeah? 1, 1, and 1. You don't need to put the 1s there. So for this one here, 1 mark for that. 1 mark for getting the product, and then 1 mark for getting the balancing right. Is that okay, Julie? Makes sense? And again, half mark off for each number that's wrong, and each coefficient that's wrong in front. This is going to be a synthesis. 1 mark for that. It's going to be calcium and oxygen, but how do they combine? Calcium has a charge of 2 plus. Oh! Calcium has a charge of 2 plus. Oxygen has a charge of 2 minus. So when I crisscross, it is going to be 1 and 1. So you get 1 mark for having CaO. Now I have to balance. Yeah.
So would you get 0.5 for CaO2?
CaO2?
Yeah.
I'll give you a 0.5, but you're going to get 0 on the balancing part as well. So the best you can get is 1.5 out of 3. Do you see why it's not CaO2? Right? Because it's 2 and 2 crisscross? I know, it's a lot to keep track of. Now we balance. I got 2 oxygens. I need a 2 there and a 2 there, I think. 2 CAs plus O2 results in 2 CaO. Number 3, this is the decomposition. 1 mark for that. So you're going to end up with, and I've made a mistake. What's the mistake that I've made? Okay, it's got to be O2. So I take a half mark off if you didn't remember that those Hofbrinkel guys, when them by themselves, automatically are diatomic molecules. Now I balance 2 and 2, I think, I hope. Number 4, I see 2 things plus 2 things. You know what? This is going to be double replacement. These 2 guys, the 2 metals, are going to switch partners. So first of all, it's a DR. What's it going to be? So the potassium is going to combine with the Cl. I'll crisscross that in a second. The barium is going to combine with the CO3. I'll crisscross that in a second. Potassium has a charge of plus. Chlorine has a charge of minus. Oh, it is going to be KCl, not K2, not something else, just KCl. Let me pause the video recording for a second. Oh, you're good? Okay, never mind. Keep going. Barium, I have no idea. Barium. 2 plus. CO3, which is carbon something. Carbonate. 2 minus. When I crisscross, I get 2 and 2, which reduces to 1 and 1. Oh, okay, you know what? It is going to be BaCO3. I didn't have to crisscross. Now we balance. Put a plus sign there. Well, I'm going to need 2 potassiums. Oh, I think that's it. That gives me 2 chlorines as well, which I needed on the left, and 1 barium. So 1 mark for the 2, half mark each for the products for a total of 1. Yes?
But if you put the BaCO3 first, nonetheless, 2 KCl.
That's fine. Yep. Yep. So this is out of 1, 2, 3, 4, 3 marks each. This page is out of 12. Keep going, Mr. Dueck. Keep going. This is almost fun. Well, depends on your definition of fun, Alex. But thanks for the vote. It's all good. What kind of a reaction is number 5? Taylor's not foolish looking at his phone or anything, because Allison seems to be looking off to the right for some strange... You back? We're good? Right? What kind of a reaction is reaction 5? This is a combustion. This is one you have to memorize. Combustion. The products are always CO2 and H2O. That gets you 1 mark. They're always carbon dioxide and water. And this explains greenhouse gases. Now I got to balance. Looks like I'm going to need to put a 3 there for my 3 carbons. And a 4 there for my 8 hydrogens. Please tell me that works for oxygens. I get 6 and 4. I have 10 oxygens, 5 there. I think blank, 5, 3, 4. So again, 1 mark for that. 1 mark for that. And then for the balancing, half mark off for each thing you're missing. The last one. Woohoo! Shut up. This is going to be neutralization. It's technically a double replacement, but this is an acid-base neutralization. So it's going to be MgCl plus, hey Ryland, what do I get when I combine an acid and a base? There's the salt and water. You're going to get this one right for sure, right? I have to crisscross MgCl. Magnesium, I think that's 2 plus. Cl is 1 minus, so when I crisscross, I'm going to get a 2 there and a 1 there, so I have to do that. So that's what you need to get 1 mark. If your subscripts are wrong, you take a half mark off. Now I balance. How many magnesiums? 1, 1. How many chlorines? 2, 2. How many hydrogens is? 2, 3, 4. 2, 3, 4. How many oxygens? 2. Woohoo! 2. There's the balancing. A 2 there and a 2 there. And of course, the token science comic. Don't be so, Meg? Okay, fine. It's worth a try. So here's quiz 2. I wanted to give you a mini quiz on everything. I had headphones out before I freak out. A little mini quiz on everything, and I want to, again, give you lots of hints about the test, so keep your ears perked, okay? I had this in front of me when I was making up the test, and I had your first quiz in front of me when I was making up the test, but I also had the lessons in front of me. It says, circle the letter of the best answer. You must refer to a periodic table and an ion chart, to be perfectly frank. Which type of reaction is the following? Here's what I see number 1 looking like. A plus B, C. I see something by itself plus a compound becomes, and then it looks like the B ends up by itself and the A and the C combine. You know what? This is a single replacement. It's easier, Tyra, when they give me the symbols, but I can do it from the English. I can visualize that. That you need to know the 6 types of reactions. In fact, you ready? As a question on the test for 6 marks, I'm going to say list the 6 types of chemical reactions. Well, that helps you identify what type they are. I won't probably ask you to recreate that part, but I'll certainly be giving you a bunch of reactions and saying, tell me what they are. Okay? What type of reaction is the following? You know what? When I see carbon dioxide and water, when I see oxygen and a hydrocarbon, this is composition. B. Combustion. Boy, am I off. Classify the reaction type. Hey, you know what? This is a neutralization because I see an acid and a base, so I would cross off A and B right now. And Ryland, what are the products for a neutralization reaction? Salt and water. You know what? That doesn't look like water to me. That looks like HOH2. That's something, but it ain't water. D. Which of the following reactions is a double replacement? Why did I cross off A right away? I see a single lead by itself. That's not double replacement. So when you ask, do you need to memorize those A, B, C? No, but you sure should be familiar with kind of what they look like, because I can cross that one out. Okay, so now I'm looking to see if they swap partners. Everything else has 2 things plus 2 things, 2 things plus 2 things, 2 things plus 2 things. Here, the Na should combine with the Br, and the Ca combine. Okay, maybe it's that one. Let me check this next one. I see the Mg combining with the Br and the CO combine. Oh, you know what? This has got 3 things. That can't be right. I should have looked at that right away. You know what? D is an acid-base neutralization. So it is B. Julia, what word did I underline? That means breaking apart. Oh, you know what? It's going to break into aluminum and oxygen, except I've made a mistake because of the Hofbrinkel thing. C. C. Okay, now we start moving into what affects reaction rate. So it's starting a campfire. You chop wood into many small pieces called kindling. Which factor makes it easier to light a fire using kindling instead of using large pieces of wood? What have we changed? Surface area. Same thing that helps you cook faster when you cut food into small pieces. Same thing that helps the reaction go faster if you grind it into a powder. Hydrogen gas is mixed with oxygen gas in a closed container. Both gases mix, but no noticeable reaction takes place. When a piece of platinum metal, the mixture suddenly explodes. Boom! Like that. After the explosion, analysis shows that the platinum metal did not change. What factor? Matt, this is a catalyst. A catalyst is a third thing, element or compound, and what it does is it increases the reaction rate without being used up itself, and there's various ways. Often what it does is it grabs the other two molecules and holds them in an alignment that makes those molecular collisions that we talked about more likely to occur. There's other ways as well, but that's one of the main ones. I'm not sure about number 8, but let's see if I can reason my way. You know what? The chain has a bigger surface area. That is why bike chains rust faster than cars. Sure, the amount of oxygen in the air, higher oxygen concentration will cause it to rust faster. Sure, if it's warmer, that will increase the reaction rate. By the way, what I should have done if I was a good test writer, as soon as I said that, I should have said B is wrong, C is wrong, and I've already turned it into a multiple choice, no, from a multiple choice into a true-false guessing question. Again, Ty, a good habit, they love these chart questions on the provincial. A good habit is put a check mark next to the line that you know is right, and as soon as you know something is right or wrong, go cross off the answers that it eliminates. Often you'll find, in fact, I said, you know what? As soon as I did that, I didn't even read the third one. Didn't need to. D. I'm going to do the same. I think so. I'm not a big fan of number 8, but I think surface area is changes. If you increase, now the question is, how do you increase the oxygen in the air? I know if you did, it would rust faster. So you know what? If you're at a high altitude where there's less oxygen, things don't rust as fast. Okay, temperature, stuff rusts faster in the summer. Wait a minute, Mr. Dueck, our stuff rusts in the winter. That's because we get more rain in the winter. Go to somewhere where it's tropical, where they get rain in the summer, stuff rusts very fast, very fast. I'm going to use a similar process of elimination for number 9. Which of the following would, Ty, what word did I underline? Slow down. That would, which means B is wrong and D is wrong. Raising the temperature, does that slow down a reaction or speed up a reaction? Why? Why? I know heat speeds it up. You said raising the temperature would speed it up because it speeds it up. Okay, it makes the molecules move faster. If they're moving faster, are they more likely to bump into each other and have chemical reactions? So that speeds it up. Matt, adding a catalyst, does that speed it up or slow it down? Speeds it up. Oh, I can now cross off C. Oh, sorry, A, because 2 is wrong. You know what? Oh, yeah, changing the shape to make it thicker and less wide, reducing the surface area. Turn the page. 10 I really had to think about. It says, okay, trial 1 was the fastest. Trial 2 was the slowest. So this is going to be in the middle. And then it asks, which was the most important in increasing the rate of this reaction? So look at the difference between the fastest and the slowest. What did we change? These two were the same. These two were the same. What made a big difference? So I think the first thing I'm going to say is surface area was the biggest impact. Oh, from most important to least important. Let's look at the difference now between the fastest and the middle. Well, here we changed 2 things, the temperature and the concentration. I'm not sure. Let's look at the difference between the middle and the slowest. Well, this was colder but stronger. So this was colder but stronger, and it went slower. So what does that mean? Which of these had a bigger effect? I'm not going to ask you one quite this tricky, but it's a good thinking question. What do you think? E? Temperature had a bigger effect, and then concentration. Because it looks like even though this was a stronger concentration, it didn't react very fast. Here, weaker concentration, but add a bit of heat, and it reacted faster. Number 11, synthesis. G. Precipitate, that's the solid that forms when two solutions are mixed. It's also called a salt. Combustion, you know what? That's burning a candle. Surface area. Is it F? Yeah. F, I guess. Neutralization, where's my acid base? C. Catalyst. Affects the E. Gedification. Yeah. Did you say burning? That's what. By the way, wax is a hydrocarbon. There's a lovely, actually, in the textbook, there's a lovely description of it. Short answer. Identify the following. There's only one reactant. I think that's a decomposition. One thing breaks up into two. One reactant is an element, the other is a compound. That's a single replacement. Two ionic compounds react to form two new ionic compounds. I think that's a double replacement. Right? Yeah? Cool. Which of the four is most important? Dust. Did they say dust? You know what? That's going to be surface area. By the way, that happens every year, especially out in the prairies. Barns explode. They have to be very cautious with venting grain barns or other barns. And I showed you guys the video of the sawdust fireball. Table sugar is digested in the mouth when it divides in saliva, which contains a digestive. You know what an enzyme is? It's a catalyst. Surface area. You want me to write it out? Surface area. A person. Ooh. Why does blowing on a fire help it to burn hotter? Yeah, you're adding oxygen. What's that? You're increasing the concentration. So 1 mark for each of those. Complete and balance the following, then classify. So 1 mark for the classification, 1 mark for predicting the product, and 1 mark for the balancing, just like the tail end of the quiz. Reaction type, by the way, this is single replacement. This is combustion. This is synthesis. You see what I mean by, do you have to memorize the pattern? Sort of. Oh, I told you I'm going to ask you on Wednesday what the 6 types of reactions are. Probably if you go hunting on the multiple choice, you'll see most of them there anyways if you blank out on some of them. You've clued in that often you can find a written answer somewhere in the multiple choice if you're looking for a word or vocabulary, right, Andrea? You picked up that trick, and if you haven't, pick up that trick. Okay. Hey, Julia. See you later. See you. See you. Okay. It's going to be by itself. Zinc is going to combine with OH. So zinc, which has a charge of, so Julie, you were wondering about the crisscross. So I find zinc, which has a charge of 2+, and I know it has to combine with the OH. You okay with that? How we predict that, right? We recognize what type it is. OH has a charge of -, so when I crisscross, it's going to be zinc, a single one, but I'm going to need 2 OHs. So for 1 more mark, you need Zn, OH in brackets 2, plus Cu. If you have the subscripts wrong, you can get a half mark of the 1. And now I balance. Oh! It is balanced. Yes? Yep. Whew! So 1 mark for leaving it blank. B. This is burning. I know the products right away. It's always carbon dioxide and water. Now I balance. Start with the carbons. I got 2 on the left. I'll need 2 on the right. Then do the hydrogens. I got 4 on the left. I'll need 4 on the right, but there's 2 there already. And holy smokes, the oxygens took care of themselves. Booyah. No, yes? What? I'm not.
The oxygen on the left.
Oxygen on the left?
Because you
Oh, I'm sorry. I was only looking at this oxygen, 2. No, I have 4 plus 2, 6 oxygens, and so I'm going to need to put a 3 right there. Good gosh, that was a brain trip on my brain there. Stubbed my toe mentally. Okay, this is going to combine into ALS, but I got a crisscross. Aluminum has a charge of, hello, aluminum, 3 plus. Sulfur has a charge of 2 minus. So when I crisscross, it's going to be Al2S3. Yuck. And now I balance. I'm going to do the S's first because I think they're going to be the yuckiest. How many S's on the left? 8. How many on the right? What do I want to turn them both into? A 24. I think I might try putting an 8 there and a 3 there. How many aluminums do I have on the right now? I think it ends up being 16 Al plus 3 S8s gives 8 Al2 plus S3. Mr. Dueck, why did you have an S8? I gave you a octasulfide polyatomic. It happens in nature. Sulfur combines with itself. And anyways, I haven't showed you all the weird chemistry stuff. An actual periodic table. Okay. So this page is, this question, number 19, is out of 9. So it's out of 3, which makes this whole page out of, count them, 18. What was this page out of? 1, 2, 3, 4, 5, 6, 7. This page out of 7, right? Well, really. Oh, and then this page was out of 1, 2, 3. And this page is out of 6. So ideally, what you really have is 16 plus 18. Hopefully it's out of 34, which is hopefully what I said at the top. I didn't say at the top. Out of 34.